Hello and welcome. So in today's video, I'm going to be going over a slightly modified example from the new CCNP security VPN Cert guide. And essentially, I'm going to talk about GETVPN. And in the book, they do an IKEv2 example. So I've basically taken the example in the book, but then made that into an IKEv2 example. So most of it's the same, and then there are some differences. Basically, we're gonna have a key server. R2 is going to kind of represent the private MPLS or just private network that allows R1, R3, and R4 to be group members of this GETVPN with the key server. So R2 is kind of our way to have routing and links across all the routers, and our key server is going to be configured to have an IKEv2 tunnel amongst all three R1, R3, and R4, so we can protect the traffic that's going to the LAN subnets that are connected to each one of those routers. So the links between the routers are going to be /30s, as I have in the notes here. And for R1, 3, and 4, they have LAN subnets, /29s. And then, so essentially, each one of those LAN subnets is inside of this /27. And that's the encryption domain for the VPN tunnel, the GETVPN tunnel that we're setting up here. So to start off, I'm going to start with the key server and get the interfaces going. So gig00 is going to be the link to R2 on the /30. We'll get OSPF running on this. And advertise the interface that we just configured. And then, so it just has the one link to R2, and we can start getting into the crypto configuration. So the first thing is going to be phase 1 policy, IKEv2, or a proposal for IKEv2. And this is going to be GCM based. So we're going to call it GCM 256 with a PRF of SHA-512 and Diffie-Hellman group 21. So GCM _ PRF SHA-512 _ Diffie-Hellman 21. So that's going to be the alias for this proposal. So encryption is AES GCM 256. There is no integrity configuration here because that's built into the GCM encryption algorithm. So we'll do PRF of SHA-512. and Diffie-Hellman group 21. And so now that we have an IKEv2 phase 1 proposal, create a policy for that to be encapsulated in. Then we just reference the same proposal that was just created. So we got a phase 1 policy for IKEv2, and we want to create a keyring, and that keyring is going to have the pre-shared key reference for each one of the peer IPs for the different routers that are going to be part of this VPN. So we will have the R1, its peer, which is the 50.6. R3 is going to be 50.10, and R4 is going to be 50.14. So essentially where this block of configuration is doing kind of defining the pre-shared key for the phase 1 negotiation, and specifically calling out the peer IPs that need to match in those negotiations. So I'm just going to paste that in. And we'll reference this keyring in a bit here. So now we'll create the IKEv2 profile that, again, is saying that we want to, when we have this phase 1 negotiation, we want to make sure that these peer IPs for our 1, 3, and 4 are part of the negotiation. Each side, both local and remote, are doing authentication for pre-shared key, which we just did in the keyring. And then inside of this profile, we're referencing the keyring that was just created. So I'll paste that in. And now we need to have a phase 2 transform set. And in this case, I'm trying to keep the naming conventions pretty straightforward. So in this case, I'm calling it GETVPN _ group 1 for this transform set. And you'll notice I've done GETVPN _ group 1 keyring, GETVPN _ group 1 _ profile. And then so that way, the naming conventions are relatively straightforward, and it makes sense. You can see what links to what. So I've made that transform set, and now I need an IPsec profile to reference that transform set. So we'll do crypto IPsec profile, GETVPN _ group 1 profile, and we want to set the phase 2 security association lifetime for 3600 seconds or 1 hour. And inside of this profile, we're referencing the transform set for phase 2 encryption that we just created. And now we need to, since we're on the key server here, we need to generate keep an RSA key pair to digitally sign the rekey messages that are going to come from the key server to the different VPN pairs in this group. And that rekey process, and in being able to encrypt that, both digitally sign and encrypt the rekey process, There's what they call the KEC, which again is kind of detailed in the book here, which is the control plane rekey process. And then the TEC is the payload encryption, or the IPsec SA. So essentially we're signing these rekey messages and encrypting that so we can send the encryption key for the KEC and encryption key for the TEC, which is basically phase 1 and phase 2 is another way to look at it. So we're going to do crypto key generate RSA, and again keeping the naming convention GETVPN_keys. So now it's generating our key pair, and that'll get referenced here pretty soon. So now we've got phase 1, we've got phase 2, we've got a key pair so we can digitally sign these rekey messages from the server, and we need to have an actual interesting traffic ACL for the VPN tunnel. And again, we're going to have 10.10.10.0/27 is our encryption domain, and that covers the LAN subnets for these routers and then hosts on that on those LAN subnets are represented by the Linux hosts here. So we got to have an access list to have for interesting traffic. And so we're just saying permit IP source on this /27 and destination same /27, because that's going to be traffic from any of these Linux hosts on these LAN subnets. And we'll reference that ACL here in a minute. And then again, I'm just calling it GETVPN_group1 for the access list, and keep the naming relatively straightforward. So now it's time to pull a lot of that together, and that's done through the crypto map entry. And in this case, we're doing the crypto GDOI, or group domain of interest. And we're calling that group GETVPN_group1. Identity number 1, server local. So we're on the key server here. And then we want to reference the GETVPN_group1_profile, which is pretty much like a standard IKEv2 profile. It references the key ring. It says we're doing authentication by pre-share on both sides, and who are the actual peer IPs that we're going to negotiate with. And again, these peer IPs are R1, R3, and R4. That'll be the GIG00 interface for those, and essentially their peer IP. So we got, where we're at, server local, and then this. Now we're getting into one of the commands that's making this GETVPN tunnel to use IKEv2 in this crypto map entry here. And then our rekey information is going unicast, and retransmit, I think that's wait 10 seconds on the retransmit, and then try 2 times before just kind of timing out completely. And then authentication for the server to send a rekey message, so we can change up the the phase 2 security, ultimately, so we can change up the phase 2 security association. That way an attacker can't just get the symmetric key for the IPsec encryption and then start looking at all the traffic. Every so often it's going to rekey and then encrypted with a completely different symmetric key. So to do that, again, it's the GETVPN keys that we generated earlier, the RSA key pair. And then the IP of the server here. So we're saying address IPv4 172.16.50.1. That's going to be the peer IP of the key server. So that's the IP for the GEG00 interface configured a minute ago. And configure an IPsec security association. And we're going to again reference that same IKEv2 profile that was referenced just a bit ago in this GDOI crypto map that we're still working on. And so now we need to specify the interesting traffic ACL, so match address, IPv4, GETVPN _ group 1. And so that's the ACL to encrypt the 10.10.10.0/27 network. And then I forget what this does. See what replay. Enable anti-replay check for single source traffic by using sequence number. So just security on the tunnel to prevent an attacker from replaying messages. Replay counter. And then window size 5. And that's just taken as an example from the book. I need to study a little bit more to understand completely what's going on there. And that is pretty much it for the config for the key server. And we'll go into R2, which is just the kind of simulated MPLS or the private network that's tying together all these routers. So just going to configure the 4 links that we have here. So GEG00. That's going to be for the link to the key server. So going back to the notes, 50.2 is the R2's link to the key server. And then basically the next 3 that we do are going to be the link to R1, R3, and R4, the .6, .10, and .14. So the GEG01 is going to be the link for R1. GEG02, the link for R3. Should be correct, that's the .9. Yep. And gig03 link for R4. So if I messed up what the links were, then gig00 is for the key server, 01 is for R1, 02 is for R3, and 03 is for R4. And then we're going to get OSPF running and use this one network here to advertise all 4 of those interfaces. Okay, and then on to R1. So the gig00 is going to be for link to R2, and the gig01 is going to be the LAN subnet for the Linux host. And then we get OSPF running for both the link to R2 and the LAN subnet on the 10.0 network. And then just like in previous videos, I'm going to set DHCP running here. That way the Linux hosts can get DHCP addresses. And then exact same phase 1 proposal and policy for IKEv2 that we did on the key server, and it'll be the same across all the other routers as well. And so in this case, now that we're doing a key ring for this R1, which is one of the GETVPN peers, we're just only needing to specify the key server's peer IP. So when we were doing the key ring for the key server, then we're specifying the peer for all 3 of the routers, R1, R3, and R4. And of course, now that we're dealing with one of the group members, we only need to reference the key server. And keeping all the naming conventions exactly the same. And then so we've made the key ring. Now we're going to make the IKEv2 profile, reference that key ring, and reference the peer IP for the key server. Now we're going to do the crypto map entry and referencing the server's peer IP and the IKEv2 profile that we just created. Okay, now we're going to do a crypto map entry. So the difference between this and the key server, you'll notice that we did a crypto GDOI group, and what I would say is somewhat of the equivalent of that for the group member is we're going to have an actual kind of standard crypto map entry, and then the key being that we're using the GDOI protocol. So slightly different configuration here between a group member versus the key server. So we're saying crypto map GETVPN underscore map, and then again with the naming conventions, GETVPN underscore map, priority number 10 GDOI, and we're referencing the GDOI group that was just configured, which in turn references the IKEv2 profile that was configured, and then that profile in turn references the keyring. So basically, the way to look at it, just like in any of the other IKEv2 videos I did, the crypto map entry is what's really tying everything together. And in this particular case, we're referencing a group, which is referencing the key server's peer and profile, and then setting the IKEv2 profile, which in turn references keyring, and keyring has the pre-shared key. And so now we've got the crypto map entry, and then the last thing is just to associate that crypto map entry with the GEG00 interface, because that's essentially the peer interface. And then as soon as I did that, you'll notice that GDOI was turned on, registration started, and I'm getting the tech and KEK security associations, and registration to the key server complete using the peer IP for R1, which is the .6. Install policy successful. So these are all good messages here. And actually, I was thinking about I meant to actually start running debug so we could look at the debug messages, but just the stuff on the console is good. Shows that everything's working. So we can do show crypto. Whoops. Show crypto GDOI, and we'll just see what the basic command shows. So group name GETVPN underscore group 1. The type is IKEv2. This is the IKEv2 profile that was configured. The IP for the group server. Local peer IP for R1, key server's IP, registration status is registered. What else do we have here? The access list that was downloaded from the key server. So the cool thing about this key server is, it's mostly pushing down a lot of the configured policy. And one of those, so we're not configuring an access list on the peer router. It's this ACL is downloaded from it, and showing the IPsec Security Association, and it's got the transform set that so yet another thing that's kind of downloaded from the key server is the phase 2 transform set, because we didn't even configure this on the router. this transform set to use for this tunnel was downloaded from the key server. So that all looks pretty good. And then it's going to be the exact same, well, not exact, but same general idea for the other two routers, which is R3 and R4. So I'm just going to run through this pretty quick, and then the whole point will be to see that the tunnel, oh, I guess that's one thing I could do real quick. So for instance, show crypto IKEv2 SA, and you can see that IKEv2 tunnel is up. Show crypto IPsec SA. And we haven't sent any traffic yet, so the security association's there, but no NCAPs or DCAPs could haven't sent traffic yet. But this is all ready to go as we move on. So now we want to go to R3. And then configure the interfaces. Get OSPF running. Get DHCP running. And do crypto IKEv2 proposal. IKEv2 policy. And set up the keyring with info for the key server. And IKEv2 profile. Same info as we did on R1. And then a GDOI group. Our GETVPN underscore group 1. Crypto map entry. And associate that crypto map with an interface outside, well, not the outside interface, but the GEG00 representing the peer IP interface for R3 for the tunnel. And then we can see same thing, success for all the GDOI stuff. So this, so we can do show crypto GDOI. So this stuff is good. Show crypto IKEv2 SA. Show crypto IPsec SA. All the basic stuff all looks correct. And then start this Linux host up. And then we'll do the last router here and verify that we get IPsec protected traffic across all three of the Linux hosts. So we got interfaces. We got OSPF. And the whole point of needing OSPF on the LAN subnets that you would normally not need in a tunnel is the whole point of the GETVPN is that it's not going across an untrusted network like you would with a standard peer-to-peer, and where you wouldn't have routing between the networks in the encryption domain. This is a case where you do have routing to everything because it's on an internal private network, but we still want to protect that traffic with IPsec. Okay, so we've got DHCP running, and we want to make the IKEv2 proposal, same as we've had on the other routers. Policy to encapsulate that proposal, and make the keyring referencing the key server. Group profile. Sorry, IKEv2 profile. GDOI group, which references the profile that was just created. Crypto map entry, which references both the group and profile that we just made. And crypto map associated with the GEG00 interface. And then same thing, everything's starting to come up. So now I'll get this last Linux host started up. So I'm logging into the Linux host on the LAN subnet for R1. So we've got DHCP address of 10.10.10.2. And take a look at this one. We've got an IP address of 10.10.10.10 on this one. This one's 10.10.10.18. So from this one, we'll ping the .2. So ping of 10.10.10.2. So we got traffic going, and we have routing, so it's not like they weren't able to communicate before, but the real key is, are we actually encrypting this in IPsec? And so if we do, so we're sending traffic from this host on R4's LAN subnet over to the host on R1 subnet, or to the 10.2. We got traffic going, and then we should now start to see NCAPs and DCAPs. So show crypto IPsec SA, and sure enough, we're seeing NCAPs and DCAPs across this 10.10.10 network. So we know that, because they were already able to communicate to begin with just by the routing that was set up, but any traffic across these Linux hosts, when it traverses any of the routers, is going to be all protected by IPsec. So we can, as these pings run, we just see the NCAPs and DCAPs continue. So we'll look at R1, show crypto IPsec SA, and again, as we expect, NCAPs and DCAPs. Now, if we look at R3, there shouldn't be anything because no traffic has really come across R3, even though the tunnel's up for it and everything. There hasn't really been any IPsec traffic to R3 specifically just yet. So if we do show crypto IPsec SA, then, security association is up like we looked at earlier, but no NCAPs and DCAPs. And then this one is the .10. So we could go ping 10.10.10.10. So we get responses on that. And then now we should expect to see some NCAPs and DCAPs, and we do. So as that ping continues to run, then we continue to see traffic encrypted and decrypted. And just for fun, we'll ping the .18. Yep, that works. And everything's working there. So that's pretty much it for the GetVPN tunnel. There are some other. Take a look at the show crypto GDOI. What do we have here? So we could do. Now let's take a look at rekey. Rekey database. Let's look at detailed. So it looks like we haven't done any rekeys yet. What else can we look at? They got references in the book, but my mic's sitting on the book, so I guess I'm not looking it up. We could just do GDUI detail. So group identity is 1. We're doing IKEv2. You can see that we have 3 group members. So that's R1, R3, and R4 are the IKEv2 group members that have all registered with this key server. We don't have any rekey. We looked at the rekey database a minute ago, and looks like nothing was in there because I guess kind of by default, the rekey or the phase 1 SA is going to its lifetime is 24 hours. So we're counting down, and it looks like the timing is slightly different. So there's looks like there's the normal phase 1 lifetime for the IKEv2 tunnel, and it looks like there's a slightly smaller, little bit less on the countdown for the rekey, and maybe that's because it's going to send the rekey messages out just slightly before the phase 1 lifetime ends. That makes sense. I could be wrong. And then again, that command that we did earlier for the rekey kind of parameters, it'll try 2 different times with a 10-second in between. So if it can't contact when it sends out rekey messages, we'll retry after 10 seconds and then stop after 2 attempts. So lifetime on the phase 2 or the IPsec SA, that was set for an hour, and then it's gonna need to reestablish just short of an hour here. What other stuff can we look at? We do a key server information, which is kind of part of looks like just same info from the detail that we looked at. And what else? See what it says for GM. Nothing for group member info. What does feature say? Interesting. So do feature for GETVP2, key server group members. So at any rate, that's pretty much it. Mostly standard IKEv2 tunnel. The main difference is we aren't going peer-to-peer, and now this whole concept of GetVPN is that you have a key server which can push like the phase 2 policy, and other details, so they don't have to be configured. So like phase 2 policy, the interesting traffic ACL, stuff like that can be pushed from the key server, and that way you don't have to configure that on every router. So we're basically establishing a group or encrypted transport VPN. So slightly different from a normal peer-to-peer. And then since this example in the book was IKEv1, it wasn't that difficult to figure out. If you already understand how IKEv2 tunnels work, like in my previous video, then it wasn't difficult to figure out how to change that example up to do IKEv2. The one thing that I would mention though is on any of the group members, you have this crypto GDOI group, and the command that I had to figure out from the documentation was this client protocol GETVP2, and then referencing the IKEv2 profile. This is the one, because that IKEv2 example for GetVPN is not in the book. It was relatively straightforward to figure out how to make this example into IKEv2, except for this particular command here. This is the one that I had to, since that was originally missing when I was figuring out this lab, that's the one that I was running debug and couldn't see what was going on, and then I started looking up the documentation, and this command here really matters, and just part of the group. So that's the one thing in documentation I really had to look up to actually get this working. But aside from that, relatively straightforward if you have experience with IKEv2 in general. So hopefully that was helpful, and catch you in the next video.